Now we're going to talk about the derivatives of inverse functions. And one of the things you have to remember is that if the point xy lives on a function, then the point yx lives on its inverse. I know that's kind of a weird way for me to say that, but in general what we know to be true is that if f of x is y, then the inverse of f evaluated at y is x. And that's important because when we're going to have a conversation about a function at x, when we're going to talk about his inverse, we need to talk about the inverse at y. So we're talking about not the same x value, not the same location on the graph, but the corresponding location on the graph. And given that this is true, then the rule goes like this, that if you have the the derivative of a function, that number is the reciprocal of the derivative of the inverse, but at the correct location. So in other words, I'm going to say it this way, that the derivative of f is the reciprocal of the derivative of f inverse. But if I'm talking about f at the location x, then I have to talk about f inverse at the location y, which was the corresponding y value for f of x. Here's what I mean by that. Here's an example of what I'm talking about. Let's say that the function that we're talking about is x squared for x greater than or equal to 0. So obviously his inverse, I wrote f prime for some reason, f inverse of x will be the square root of x. Then what I'm claiming is that f prime at, let's say some random x value, let's say 3, f prime at 3 will be 1 over f inverse prime, but not at 3. The corresponding location would be at 9. So a function and its inverse have reciprocal slopes, is what we're saying there. So when you take the derivative at the correct location, so you have to be careful about that. But other than that, that's true. The only other piece to this section is the basic memorization of inverse trig derivatives. So I'm going to write those out, and then it's just a matter of you memorizing them. So much like back when we were talking about the derivative of trig functions, I said, hey, go ahead, memorize these. I'm going to say the same thing here. And let me list these three. I am going to be honest with you, they don't come up very often. So you do need to know them, but it's not going to be a focus, especially on the AP exam, and therefore it is not going to be a focus on, let's say, our final exam. The test for this chapter will cover it, of course, but in general it's not going to be something that you're going to need to know in super great detail. Just memorize them so that you can bring them out on demand. The reason I did them in the order I did is that if you can remember the first three, the derivative of inverse sine, inverse tangent, and inverse secant, then the other three, the co-versions of those, are extremely simple because you just take the opposite of what the regular version was. So the derivative of inverse cosine is negative 1 over 1 minus x squared. And so for inverse cotangent, it's negative 1 over 1 plus x squared. And the same idea is true for inverse cosecant. So memorize these, know them, and that's about all you're going to have to do. You're going to have to do a few problems with them, but it's not going to be a big deal.